Hi, good morning to you all. I hope you guys are all doing well. Today we are going to be covering solving right triangles using trig functions with emphasis on angles of elevation and depression to solve problems. Some things that you need to keep in mind when you're solving these is the process of determining the three angles and the length of the three sides of a triangle is called solving the triangle. And a right triangle can be solved if we know either the lengths of two sides or the length of one side and the measure of one acute angle. So that's super important that you understand that. So when you're taking notes, you want to make sure that you underline this and then make sure that you know that you either have to have two side lengths or the length of one side and the measure of the acute angle. Okay, next, when you're solving a right triangle given one side and one angle, you are going to be solving this by looking at angle B, right? And it can be found since angle A is 32 degrees and we don't know what angle B is, but they are complementary angles and we know what angle C is. So angle C is going to be 90 degrees. So if we are looking at the triangle as a whole, this is 32 degrees. This is 90 degrees. And 90, right? So it's, it's also written right here, 90 minus 32. So this angle, right, minus this angle is going to give you 58 degrees. So either angle A or B in the trig ratios can help us solve for the remaining sides. So if we have 90, this is 32, this angle would be 58 degrees. We are still missing side lengths A and C, but we know side length B is 15. So when you're looking at these figures, you definitely want to clearly identify the things that you know and the things that you don't know and things that are missing in hopes to help you. So this is solving a right angle given one side and one angle. So if you look here, we want to figure out, okay, what are we missing? So we are missing C and we're missing A. And if you can remember, this was 58 degrees. So we can figure out what the length is using cosine of A. So if you use the cosine of A and you use the adjacent and the hypotenuse, we can use this 32 degrees with which is what is given. And this would be the adjacent side because it's right next to that angle. And this would be the hypotenuse side because it's the longest length. So we can use the ratio over here, the cosine of A. So cosine 32 degrees. And then you put that adjacent number, which is 15, over the hypotenuse, which we saw is C. And we can rearrange this in order to solve for C. So when we arrange this, like I have showed you before, we have the cosine of 32 degrees. This equals 15 over C. If you're dividing by C, you can isolate this by multiplying by C. So you multiply both sides by C, you have C cosine of 32 degrees equals 15. If I want to isolate C, these are being multiplied, so I can divide by the cosine of 32 degrees. And this will isolate C. So this is the same process that is done for you over here. You have the 15 that's isolated, as I did over here. You have 15 divided by the cosine of 32 degrees. And then you take the cosine of 32 degrees, which is 0.8480. When you put that in your calculators, you can use the scientific calculator for Desmos, or you can also use your graphing calculator. So you would take 15 and divide it, and then you would get that C. So the side length C, we're not talking about the angle, we're talking about the side length C, is approximately 17.7 units. And we say units because that it doesn't give us a feet, yards, anything like that. So we just clearly say units. Now, next, we're going to look at what we can do to find the side length of A. So we now know that this is 17.7. We now want to use this same angle measurement for angle A, and we want to find what this side length is. So we are going to look and see what we are given. So we are given that 32 degrees is the measurement for angle A. We know the adjacent side already, and we are trying to find the opposite side. So this is the opposite side. So we want to look at these and say, okay, what tangent ratio can we use with opposite and adjacent? Well, if you remember SOHCAHTOA, the TOA is TOA. So we can use the tangent of 32. So we can use tan 32, and then we can use the opposite, which is A, over adjacent, which is 15. So in order to solve for that, we can do the same method that we did on the other side, which is we would multiply by 15 on both sides. Okay, and then we have that down here. We have equals A. So we don't have to move anything else, right? So we're going to do the tangent of 32 degrees, which is 0.6249, and multiply that by 15. And that's what A equals. So A is equal to 9.4 approximate. So this is the unit, because we don't know what measurement that's in. So we just put units. So the angle B is 58 degrees. Angle A is approximately 9.4 degrees. And C is approximately 17.7 units. So I'm hoping this helped you clearly understand how to find the missing side links, and then sometimes how to find the angle, especially when you know that this is a right triangle. So here's our next example. It says solving a right triangle given two sides. So solve the right triangle if needed, round any answers to one decimal place. So in this situation, because you have a right triangle and you're trying to find the longest length, which is the hypotenuse. The hypotenuse, and I just abbreviate it, is F. So trig functions are not needed for this. You can use the Pythagorean theorem, which is a squared plus b squared equals c squared, where c is going to be the hypotenuse. And then this is one of the legs and one of the other legs. And this only works if you're trying to find the hypotenuse, or if you have two other triangle legs in a right triangle. Okay, so you have to have two. So with trig, you use the trig ratios because you have an angle measurement, right? So right here, we are going to plug in the 9, right, for one of the legs, the 5 for the other leg, and you square these numbers. So it's like 9 times 9 equals 81, 5 times 5 equals 25, and then you get together, when you add them, 106 equals f squared. So when you take the square root of this, you get a decimal of 10.3. You are going to take the square root because we don't want to know what f squared is. We want to know what f is. And the opposite of squaring something is taking the square root. So you can make yourself a little note. And this is an important fact to know, just how we know how multiplying is the opposite of dividing and dividing is the opposite of multiplying. You need to know that the opposite of squaring something is taking the square root. So squaring is the opposite of square root. So that's definitely an important factor. So the opposite of squaring something, so we squared it over here. If you square one side, you have to square the other side, and that's how you got that 106. And 106 is not a perfect square root, but I know that if I were going to do this in my head, it's going to be between the perfect square roots of 100 and the perfect square root of 121, which the perfect square root of 100 is 10, and the perfect square root of 121 is 11. So I know whatever my answer is going to be between 10 and 11. And if you do put that in the calculator, that's how they got the 10.3. Because with these, you are allowed to put them in the calculator. And it's best to definitely make sure that you estimate and approximate the decimal. So that's like a little bit of a review going over Pythagorean theorem. So next, I'm going to talk to you a little bit about solving a right triangle given two sides. Next, we're going to find angle D or angle E. and we're going to choose which one to solve first. So what we can use is we are given, if we're looking at D, right? So if we want to find angle D, and we'll use the Greek symbol of theta. So we're going to find D, and we are going to be looking at what has been given to us. So we have, from D, we have the opposite side length. And then we have the one next to it, which is the adjacent. We just calculated what F is, but we're not going to use that since it's not given to us in this example. So we have the opposite, and then we have the adjacent, right? So we are going to look and say, okay, opposite and adjacent. So that whole SOHCAHTOA, we are going to use the TOA part, right? So this is tangent. So we can take the tangent of D and put down the opposite, which is 9, and the adjacent one, which is they're sitting right next to each other. Okay. And you can remember this, like think about people sitting in a desk, right? And then think about, okay, D is sitting next to 5 in F. Well, F is the longest length, so that's going to be the hypotenuse. So its other little table partner over here is the adjacent one. That's a helpful way to remember that. So it's sitting right next to 5. So that's the adjacent. So we have tangent D and then 9/5. Well, since we are looking for an angle, right? So we're looking for an angle. We want to use the inverse property. So you can put the tangent inverse times 9/5 to calculate the angle measurement. So angle equals inverse. Just remember, keep that in your heads and remember that. So angle equals inverse. That's like a helpful hint and tip to help you remember that. And our angle is going to be 60.9 degrees. And that's just a helpful way for you guys to memorize that. Thank you for letting me review the inverse properties of trig, and for letting me review with you how to solve right triangles given two sides.